Welcome to today's deep dive into SpaceX's latest upgrades at their launch pad. You may have seen the intense flames and thunderous roar as rockets lift off, but have you ever wondered what goes on below? Crater damage from rocket blasts used to be a big concern, but not anymore. Let's break down how SpaceX has engineered solutions to avoid this issue, all while prepping for some of their biggest missions. Before we dive into the solutions, let's understand the problem. Every time a rocket launches, it releases massive amounts of thrust, causing the surface below to erode and even crater under the pressure. Think of the Apollo missions where launch pads often sustained serious damage. This problem has been a huge challenge for engineers over the decades. Now, why was it critical for SpaceX to upgrade their launch pads? The answer lies in their next-generation Starship rocket, which is the largest and most powerful rocket ever built. With this immense size and power, the risk of crater damage grows even higher. SpaceX had to rethink its launch pad design to support these ambitious missions. To counter the intense heat and force, SpaceX implemented two key systems at their launch pads: the flame trench and the water deluge system. These innovations help redirect and absorb the energy from the rocket blast, protecting the launch pad from cratering. Now let's take a closer look at each part of the upgraded launch pad. The flame trench, built directly beneath the rocket, channels the rocket's exhaust sideways, preventing it from hitting the ground directly. Meanwhile, the water deluge system is activated seconds before launch, releasing thousands of gallons of water to cool the exhaust gases and suppress sound waves. These upgrades have already proven successful. Recent launches show how effectively the flame trench and water systems work together to prevent crater damage. This success is critical not only for Starship but for the future of Mars missions and beyond. And that's a wrap! SpaceX's launch pad upgrades have not only solved a massive engineering challenge, but also paved the way for safer, more powerful launches in the future. What do you think? Are we one step closer to Mars because of these innovations? Let us know in the comments, and don't forget to like and subscribe if you enjoyed today's breakdown.